Today's lecture, I'm going to go ahead and begin with statistics. And the first topic that I'm going to start with in statistics is going to be probability. We're going to go step by step. So I'm going to begin with the basics of probability for today. What is a set? How do we connect sets to probability? And then slowly we'll pull off this thing to talk about distributions in probability. We'll see what are the various distributions, normal distribution, binomial, etc., etc. We'll try and link each of that back here and we'll see how different distributions play a role. Once you understand normal distribution in particular, you will see that it makes much more sense for you to go ahead and understand back econometrics, where we were talking about various assumptions of the CLRN model and talking about what is the normal distribution. So to begin with, let's understand what is an experiment. See, an experiment is any activity that involves uncertainty or that involves randomness. For example, if I talk about maybe tossing a coin, then it can lead to head or tail. Because there is uncertainty in what I'm going to achieve, whether I'm going to achieve heads or I'm going to achieve tail, therefore it becomes an experiment. Similarly, let's say that I have to cross a road, and that road can have red light, green light, orange light, etc. So that again, yellow light, etc. That becomes an experiment. So anything that is subject to uncertainty or randomness is called an experiment. Now, to give you examples, tossing a coin once or several times, selecting card from a deck, throwing a dice, raining, not raining, all of these are experiments. Now we want to go ahead and understand what is a sample space. A sample space is all possible outcomes of an experiment. So for example, when I throw or toss a coin, I can only get head or tails. That becomes my sample space. When I talk about throwing a dice, I can get 1, 2, 3, 4, 5, 6. That becomes my sample space. So sample space, to be precise, of an experiment, it is denoted by S. And it is the set of all possible outcomes of an experiment. All the possible outcomes. I would be going ahead and contrasting a sample space with an event very soon. But first of all, understand what is a sample space. A sample space is a bigger thing. It's a bigger set. It consists of all possible outcomes of an experiment. So for example, when you toss a coin, sample space is head or tail. When you toss two coins, sample spaces that both will be head, both will be tail, first head, second tail, second tail, first head, first tail, second head. So again, this is the sample space. All possible outcomes is called a sample space. Let's see this. So take example 1. I'm running an experiment. My experiment is to check whether the bulb is defective or not. And to run that experiment, I need to formulate a sample space. And my sample space has two things. Either my bulb would be defective or my bulb would not be defective. So I get two possible outcomes out of it, not defective and defective. Because I have listed all possible outcomes, therefore, that becomes a sample space. Let's take one more example. So, my example is that the experiment is observing gender of the next child that is born in hospital. Again, my sample space is going to consist of all possible outcomes, male, female. So when I give all possible outcomes of an experiment, that becomes my sample space. Now, let's take one more example. Consider 3 fuse in a sequence and note the result of each of it. So each of the fuse, can either be defective or it can be non-defective. But I have to check for the 3 fuses together. So, I pick up the first fuse, it can be defective or not defective. I pick up the second fuse, it can be defective or not defective. I pick up the third fuse, it can be defective or not defective. So, how many such possible outcomes are there? Now, let's see this. Either all the 3 fuses are defective, or the first 2 are not defective, or first 2 are not defective, but third is defective. First defective, second 2 not defective, all 3 defective, and so on. So in total, there can be 8 possible outcomes. And how do I know that? I know that because I have to fill 3 spaces. For the first fuse, for the second fuse, and for the third fuse. The first fuse can take 2 possible outcomes, defective or not defective. So there are 2 possibilities here. The second fuse can also take 2 possible outcomes. The third fuse can also take 2 possible outcomes. So based on that, I can have 8 possible outcomes. The first can turn out to be defective or not defective. The second can turn out to be defective or not defective. So for the first being defective or not defective, I have to check all permutation. When the first is defective, second can be defective or not defective. When the first is not defective, second can be not defective or defective. Similarly, for the third one also, I have to check all possible outcomes, right? So when I make all such outcomes, for example, in all these cases, the third one is defective. And then the third one in the next 4 cases, I have to say is not defective, taking the first 2 as is. So when I take all possible outcomes, that becomes my sample space. Now, let's take one more example. 2 gas stations are located at certain intersection. Each has 6 gas pumps. Experiment. Number of pumps in use in each gas station. So imagine this. I have 2 gas stations. One is here and one is here. This gas station has 6 gas pumps. This gas station also has 6 gas pumps. My experiment is to check how many of these gas pumps are working on any particular day. So it's possible that 0 gas pump is working. It is a possibility that 1 gas pump is working. 2 gas pumps are working, 3, 4, 5, or 6. Similarly, for this case, it is a possibility that none is working, 1 is working, 2, 3, 4, 5, and 6. So, how many such possible outcomes? Well, let's go ahead and check. For the first gas pump, I can have 0, 1, 2, 3, 4, 5, 6. Here also I can have 0, 1, 2, 3, 4, 5, 6. Right? So here I can have 0 gas pump for the first one and 0 gas pump working in the second one. 0 gas pump of the first one, but 1 gas pump of the second one. 0 gas pump of the first one, but 2 gas pumps of the second one. and so on. You can fill this off. Here I will have 6 gas pumps working for both of them. So this is my sample space. How many such possible outcomes? So the first gas pump can have 7 possible outcomes. 0 gas station working, 1 gas station, 2, 3, 4, 5, 6. And the second one can also have 7 possible outcomes. So in total, I can have 49 outcomes. Okay. This all this is my sample space. So if you go here and check, this entire is your sample space.